When you look at an airplane wing closely, you may notice that the top part is smoothly curved while the bottom is relatively flatter. This design is not a coincidence, it is a critical feature that allows airplanes to fly. The curved shape of the wing is called an airfoil, and it plays a major role in generating lift, the force that keeps the airplane in the air. But why exactly are airplane wings curved on top? The answer involves the principles of aerodynamics, air pressure, and the movement of air around the wing. The most important reason for the curved top is to create low pressure above the wing. Airplane wings are designed based on Bernoulli's principle, which states that when air moves faster, its pressure becomes lower. Because the top of the wing is curved, air traveling over it has to move faster and farther compared to the air moving under the wing. As a result, the pressure on top of the wing becomes lower than the pressure below it. The difference between these pressures creates lift. In simple terms, the wing is pushed upward by the higher pressure under the wing. Let's imagine that an airplane is flying forward. The air splits at the front edge of the wing. One part flows under the wing, while the other part flows over the top surface. The curved top makes the air move faster as it travels farther. Faster air means lower pressure. Meanwhile, the bottom of the wing is shaped to slow the air down slightly, which creates higher pressure. This pressure difference generates lift, which is essential for flight. Without this curved shape, airplanes would have a much harder time lifting off the ground. Another reason for the curved shape is to improve aerodynamic efficiency. The smooth curve reduces air resistance, also known as drag. Drag is the force that opposes the movement of the airplane through the air. The more drag a wing produces, the more fuel the airplane must use. By using a curved top surface, engineers can ensure that airflow remains smooth and attached to the wing, allowing the airplane to fly more efficiently. The curvature also helps control stall, a dangerous situation that occurs when the wing loses lift. If the wing is not shaped properly, airflow may separate from the surface of the wing and create turbulent air. This causes a sudden loss of lift, which can make the airplane drop or lose control. The curved shape of the wing helps keep airflow attached to the wing surface longer, greatly reducing the risk of stalling during flight. The angle of the wing, known as the angle of attack, also works together with the curved shape to generate lift. When the airplane tilts slightly upward, the wing meets the air at an angle. This increases the pressure difference between the top and bottom of the wing. However, if the angle of attack becomes too steep, the airflow separates from the wing, and a stall can occur. Pilots must carefully control this angle, especially during takeoff and landing, when lift is most critical. Modern wings are designed using powerful computer simulations and wind tunnel tests. Engineers study how air flows over different shapes and adjust the curvature to maximize lift and minimize drag. Some wings even have winglets at the tips to reduce turbulence and improve performance. In addition, the curved shape helps distribute pressure more evenly across the wing, which makes the structure stronger and more stable. Interestingly, this aerodynamic feature is also found in nature. Birds, for example, have wings that are curved on top and flatter underneath. The similarity between bird wings and airplane wings shows how humans often learn from nature when designing advanced technology. This concept is known as biomimicry, and it has inspired many features of aircraft design. Although most airplane wings have a curved top, there are variations depending on the type of aircraft. For example, military jets may have thinner wings to allow faster speeds, while gliders have large, highly curved wings to maximize lift at low speeds. Commercial airliners use a balanced design that provides both lift and efficiency for long-distance travel. Regardless of the variation, the curved top remains a fundamental feature of wing design. In conclusion, airplane wings are curved on top mainly to create low pressure, which generates lift according to Bernoulli's principle. This design also helps reduce drag, prevent stalls, and increase overall aerodynamic efficiency. Without the curved shape, airplanes would struggle to fly smoothly and safely. It is a simple but powerful idea that makes modern air travel possible. The next time you look out of an airplane window, remember that the elegant curve of the wing is one of the most important reasons you are soaring through the sky.